Okay, what I want to go ahead and do is take a look at review for test number 4. As you can see, this is part of your test review, but I am not going to go over all of this. You can check the key for that. But what I want to go ahead and do really is just take a look at this page right here. We're going to go ahead and jump right into it. Use the picture of the cube to tell the following segments are parallel, perpendicular, or skew. So I have this image, this is my cube, and my goal here is to take a look at these two segments and tell me, okay, is it parallel, perpendicular, or skew? So here's BC, so this is segment BC, and then HG would be right here, okay? So notice that this segment is part of this plane, and then this segment is part of that plane, and they're not going to intersect, okay? And from our point of view, because this is on paper, yes, it looks like it's going to intersect, but if I actually take this image and then I actually have a cube in my hand, well, if I were to look at these two segments, like, literally in my hands, well, they're not going to intersect whatsoever, okay? So that's actually skew. So we'll call this skew. All right. Now let's go ahead and take a look at segment AI. So here's AI, and then segment AD. So it's right here. And notice that with a square, right? This is the face of a cube is a square, and usually with squares that all the angles of the square is 90 degrees. So this segment is actually going to intersect that segment at a 90-degree angle. So that's going to intersect at a 90-degree angle, right? So when a segment intersects another segment at a 90-degree angle, it's really perpendicular, okay? Upside down T or T or whatever, yeah, you can see it right there. That's definitely perpendicular, okay? Let's go ahead and take a look at number 3. BC is right here, and then AD is right here. Notice that these two segments are on the same plane, okay? So since these are never going to intersect and they are on the same plane, that's what we call parallel. So that's parallel, okay? Number 4, write an equation to solve for x, then determine the following angle measures. So the measure angle 2 is 3 times the quantity 2x minus 4 minus 1. And the measure angle 4 is 5x. And just based on this picture right here, I have these two lines that intersect and they form, well, it's an x, right? That means that the angles across from each other are congruent. So we can say that angle 1 is congruent to angle 3. And then angle 4 is congruent to angle 2. So why? That's because of vertical angles. Okay, because of vertical angles. So that means that all I have to do, because I know that angle 4 and angle 2 are congruent because of vertical angles, I just have to set them equal to each other. So I do 5x is equal to 3 times the quantity 2x minus 4 minus 1. Then I'm going to distribute using the distributive property. So I have 5x on the left-hand side is equal to 3 times 2x is 6x. 3 times negative 4 is negative 12. And 3, then that's just the minus 1. You don't distribute the 3 and the negative 1. The only thing that you distribute is whatever's inside the parentheses, just like what I have here. So don't make that mistake. I almost did. Don't make that mistake. So then I'm going to combine like terms. So 5x is equal to 6x minus 13. Then I'm going to subtract both sides by 6x because I want to have the variable on the left-hand side and the actual number on the right-hand side. So I got negative x is equal to negative 13. Then you're going to go ahead and just divide by negative 1 because what's negative x? That's the same thing as negative 1 times x. So you're going to go ahead and divide both sides by negative 1. So that negative divided by a negative is actually a positive, okay? So there you go. You just figure out what x is equal to. So you're not even done though, because now I got to figure out what the measure angle 2 is. And this is the trick. The trick here is that you notice that this is a very, very long expression, right? This is a very, very long expression. So rather than, because I know that 4 and 2 are congruent, right? You know that 4 and 2 are congruent. Rather than me just taking this and plugging it in here, how about I just plug it in here? Okay, because that's just very, very simple, because I know what 5 times, replace the x, because you know what x is equal to. 13 is. 5 times 13, that's 65. So if the measure of this angle here is 65, then this has to be 65 as well. So they're both 65 degrees. And see that? That's because you know your theorems, right? You know what vertical angles are, and the vertical angles across from each other are congruent if they, if you have a figure that looks like an X, right? So why? Why do I need to plug it in here when you know this? And if you know this, you know this, right? All right, so enough of that. So my goal here now is to figure out what measure angle 3 is. And measure angle 3 is right here. And y'all, I don't need this 5x anymore because I know how long measure angle 4 is. That's actually 65 degrees, right? So now, look at this. I have that information. This right here, this angle and this angle, they form a linear pair. So that means that these angles are supplementary. So I have a part of that 180, and I don't even know what this is. So essentially, I just do measure angle 3 is equal to 180 minus 65, which is 115 degrees. So this angle here is 115 degrees. How easy is that? Okay? That's just because you know your linear pair vertical angles. If you know that, you're good. Number 5, determine the value of y and find the measure of angles 1 and 2. So find y, that's the first thing that I have to do. Look at my given right now. Measure angle 1 is 2 times the quantity y plus 20. And then the measure angle 2 is 2 times the quantity y minus 5 plus y. Okay? And from the picture, I can see that we have parallel lines cut by a transversal, right? So these lines are parallel. So these lines are parallel and cut by a transversal. Okay? So looking at 1 and 2, angles 1 and 2, are they on the opposite side of the transversal or are they on the same side? Well, they're going to be on the same side, and they're both interior angles, right? They're inside the parallel lines itself. So that means that these angles are supplementary. Same side, supplementary. It's sort of like the alliteration sort of thing. So same side, supplementary. I have to take these angles and add them up to 180. So 2 times y plus 20, right, plus 2 times y, or 2 times the quantity y minus 5 plus y is equal to 180. Then I'm going to distribute. So I get 2y plus 40 plus 2y minus 10 plus y, combine like terms. So I get 5y plus 30 is equal to 180. So then I subtract both sides by 30, so I get 5y is equal to 150, right? Am I doing this right? 2 times y. I'm looking at the key right now and seeing if I'm making a mistake or the key is making a mistake. It looks like the key is made a mistake. Okay, so then 150 divided by 5, that is y equals 30. Okay, so that's y is equal to 30. So then, since I know that y is equal to 30, and my goal here is to figure out what measure angle 1 and measure angle 2 is, well, I can just go ahead and start evaluating. So 2 times 30 plus 20, y'all, that's 2 times 50. So that is 100 degrees. And then over here, it's 2 times 30 minus 5 plus 30. So 2 times 25 plus 30, that should be 80, right? What you could have done is, since you know that these are supplementary, right, you can just, if you know what this is, do 180 minus 100, which will give you 80, okay? So that's the answer. Determine the value of x so that A is parallel to B. So this is just using the converse theorems, right? And if the angles are congruent and they are, they follow the converse theorems, then we can assume that the lines are parallel, okay? And I don't know why these lines are here. We can't assume that they're parallel, but they're there. So what we can say is that we can just definitely ignore them if we want to. But, that's really what the question is saying. Just proceed as normal, okay? Just don't let that confuse you. But when you get to the proofs, you have to know the difference between the, the original theorems versus the converse theorems. So 1 and 2. The measure angle of 1 is 3x plus 4, and the measure angle 2 is 5x minus 12. So I have these lines cut by a transversal. So if I compare this region to this region, if I were to stand at 2, you'd be standing at 1, right? So if you were standing, at 2 in this region, it's kind of like saying you're standing at 1 at this region, right? They're pretty much identical. If you look at the x's that I draw here, we're talking about like locations. So what I'm talking about here is basically the corresponding, these are corresponding angles, okay? Or they follow the, you would say that by the corresponding angles converse that these lines are parallel if these two angles are congruent. So let's go ahead, and since these are, we're going to assume that they're congruent. So 3x plus 4 is equal to 5x minus 12. Subtract both sides by 2x, add both sides by 12. So you get 16 is equal to 2x. So x is equal to 8. And that's all I have to do, okay? So that is the first page of the review.